study every day. The conservation of linear momentum states that total linear momentum in an isolated system remain constant or is conserved. You need to know that. You need to know that. Okay, so today I want us to talk about what we call elastic collision and inelastic collision. Elastic collision and inelastic collision. I want us to talk about these two things. If you remember, when we write the formula of the conservation of linear momentum, it states that total momentum before is equals to total momentum after. Why? Because momentum is going to be conserved. It is written as m1 v1 plus m2 v2 is equals to these are initial momentum during the initial stage. M1 v1 f plus m2 v2 f, the final momentum, right? So you can see that we've got momentum of the first object and the momentum of the second object. This, it simply implies that we are talking about two objects. It simply implies that we're talking about two objects. And that's where elastic collision and inelastic collision comes in. You understand? When we talk about collision, we are talking about a situation where two objects collide together. You see, I'm holding a calculator. When we talk about collision, we are talking about this situation. That's a collision, right? They've collided, right? So, there are two types of collision: elastic collision and inelastic collision. And that's what we need to learn about. Okay. I remember last year when I was teaching, I gave examples for elastic and inelastic collision, and it created confusion when we try to think deep about it, because it could not make sense for some of the people later on when we're trying to answer the questions. So I'm going to change the examples. Okay, guys, when we talk about inelastic collision, right? Inelastic collision, we are talking about a type of a collision whereby the two objects, they are going to form one unit. They are going to form one thing. You know, when we say something is elastic, you can think of a rubber band, right? A rubber band, right? You can stretch a rubber band. So when we say something it is inelastic, it means it is unstretchable. You cannot stretch that thing, right? Because it is inelastic. So, talking about collision, you can think about two cars colliding together, a head-on collision of cars causing an accident, right? That is an example of a collision. A head-on accident is an example of a collision, right? Even if another car hits another at the back, it's still a collision. Collision is two objects coming together. But these collisions, they differ. There's a collision, like having these two calculators colliding together. You see that this calculator, as they collide, they don't become one thing. You understand? You know that it is possible that for two cars to collide like this, and they form one thing, they join each other because of how severe the collision is. Don't you think so, Blessing? It seems as if you don't think so. Like two cars colliding together and they join each other. Guys, can't you imagine that, the picture of what I'm saying? Do you think it's possible? Yeah. No, like things like this. Let me give you an example. Here it is. These calculators, right? Here they are. I make them collide, then they form one calculator. Didn't they form one calculator? They've joined each other just like car. Can't you imagine cars doing that? They collide until one car stuck on another car. A chairs collide with a hose and train, a truck. You find that the chairs stuck inside the hose and train, and the hose and train move. And the hose and train, it's a collision. It's a collision. And the hose and train moves with the chairs. You understand? Yeah. Do you imagine that situation, guys? Yes. That was a mistake. Do you imagine that? Do you understand what we mean by collision? Yeah. Okay, now I want, before I state the concept formally, I just want you to understand in your own way. So, a collision which is inelastic collision. The throwing of the calculator was a mistake, guys. The collision like this one, look. This calculator they've just collided, right? They did not form one calculator. So we know that collision is what? It's elastic. I can say informally elastic. I'm just trying to explain so that you understand, because we cannot say it is elastic without proving it. But because this object they did not join each other like this, we can say it is elastic. Because when the object collide, one object is going to go its own way. You understand? Yes. Huh? Not necessarily function. We're just talking about, we're just simply talking about collision. Guys, we're not talking that they're going to form one thing or exist together. The more value the bisana, the lab the function, the common the meltive buzz now. You don't have to understand it. I'm not saying that these cars, when they collide, they co-function. Then we're trying to make a car into a taxi. No, we're not trying to do that. It's simply a collision. Okay, let me explain Chitong. Collision. Shula kubisana kaswilo. Kubisana kaswilo swi dinga ku sweswo swi tirha swin'we. A swi lavi no swi bisana swa i mhaka ya xilungu. You understand now, man? You understand? Collision simply means kubisana ka swilo, ani kuna kubisana ku hambana kuna ku swi bisana swilo swi joinana swi va xixin'we swona. Kuna ku swilo swi bisana movha fika yi bisa yin'wana mara tlhe ti hambana swona. That's what I want you to understand, that elastic collision, the objects are going to collide and they are going to separate, right? In elastic collision, the objects are going to collide and they form one thing. You understand? That's what we mean. So, okay, let us write the characteristics of elastic collision. And those one of inelastic collision. Right? The characteristics of elastic collision and those ones of inelastic collision. You understand? Okay. I've already made you to understand what is happening between elastic collision and inelastic collision. Did you understand what is happening? Did you understand in your own way? Yes. Are you sure that you understood in your own way? Yes. You need to understand in your own. Okay, let us continue. Okay, elastic collision. Elastic collision. In elastic collision, there is no deforming of object. No deforming of object. And please don't go home and sit down and you study these things a lot, trying to cram 1 point by 1 point. It's not going to be said like that. Just know the information, right? It's the kind of information you know in passing. Don't sit down and try to cram that. Oh, Mr. Bila, we set that table. No deforming of object. No, we don't do that, right? We're just explaining these things so that we can understand. No joining of objects. In elastic, there's no joining of objects. When the object collides, you see these calculators, they did not join each other, right? The object, they do not join in elastic collision, right? The internal energy of object remain constant. Internal energy of objects remain constant. The internal energy of object remain constant. What does that mean? It means that energy is conserved here, right? Energy is conserved in an elastic collision. In an elastic collision, energy is conserved. As I've told you that the internal energy remains constant. Okay, what does that mean by internal energy? We're talking about the kinetic energy. This is a very important point. It's a very important point. They can ask you a question. They give you some velocity, they give you the mass, and they ask you if it's an elastic or inelastic collision. Listen to this, it's a very important point. It's a very important point. Let me write direction here. Direction. After teaching you this, I must teach you this. It is not in any book, I just want to explain. Remind me now, after writing the points for you. Okay, this is a very important point, right? Kinetic energy. Kinetic energy. Kinetic energy in an elastic collision is conserved. Kinetic energy in an elastic collision is conserved. There's a formula for kinetic energy. Do you know it? You learned about it even in grade 8. No, not grade 8, grade 10. Kinetic energy. Kinetic energy. For kinetic energy, we write the word EK. You see EK? We're going to talk more about kinetic energy in this grade. This EK represents kinetic energy. I don't have space, I won't write. Please write. EK means kinetic energy. EK, let me write that. EK is a subscript, imply kinetic energy. EK imply what? Kinetic energy. So kinetic energy is given by 1/2 mv squared. It means kinetic energy, this is the formula for kinetic energy. Half of mass multiplied by velocity squared, right? What does it mean? It means in an elastic collision, right? Kinetic energy is conserved. What do we mean when we say something is conserved? It means that 1/2 mvi squared is equal to 1/2 mvf squared. Initial kinetic energy is equal to final kinetic energy. That's what we mean when we say something is conserved. It remains the same. What do we mean when we say it remains the same? It means during a collision, isn't it? This object will be moving at a particular velocity. They collide. This calculator will break it. Let me move this so far. Okay. They collide, right? Look at it. They collide. They are moving at a particular velocity, right? They collide. When they collide, what will happen? The kinetic energy before they collide is equal to the kinetic energy after they've collided. When we talk about the conservation, when we say something is conserved, it means initial is equal to final. That's why even that the main topic of what I'm showing you is called what? The conservation of linear momentum, which means initial momentum is equal to final momentum. We are having mass number 1 or momentum 1 and momentum 2 because we are dealing with two objects. You understand? In that situation is because we're dealing with two objects. Because the object, what is happening with them? The objects are colliding. That's why we're having M1 and M2. You understand, right? Okay, so it's like this. I've given you the example of elastic collision and inelastic collision, right? Don't make a mistake like this. They can ask you a question. Whenever they ask you a question that is this a collision elastic or inelastic? Don't make a conclusion because these cars, they have collided and separated, right? Or they've collided and stuck on each other, and you make a conclusion. They can ask you a question, give you 3 marks. They say 3 marks, explain if we have an elastic collision or inelastic collision. What you need to do, you know that if it is elastic collision, what? Kinetic energy is conserved. If it is not, if it is inelastic collision, kinetic energy will not be conserved. Guys, when we mean that, when we say that kinetic energy is conserved, when we say that kinetic energy is conserved, it means when you calculate the answer, if you find 2 here, even this side you find 2. In a situation whereby if you find 3, this side you find 2, it means it is not conserved. Because conserved means it must be the same on both sides, right? Yes. For what? For elastic. So in a situation when they ask that, is this elastic collision or inelastic collision, it means you make a calculation of what? Of kinetic energy. When you make a calculation of kinetic energy, what do? You conclude. If you find answers on both sides being the same, it means it is elastic. If the answers are not the same, it means it is inelastic. You understand, right? Okay, let us continue. I told you that they may ask you a question that is kinetic energy conserved or not conserved. They give you a particular scenario. You don't just conclude by looking at the scenario. You do what? You calculate the kinetic energies using the formula, this formula. Then you compare the answers. If the answers are the same on the left and the right, it means it is conserved. If the answers are not the same on the left or the right, it means it is not conserved. Okay, thank you. Let us move forward. So, in elastic collision, what is happening? There's what? Deforming of objects. Deforming of objects. There's deforming of objects. The object they join. The objects join each other. What do we mean by object joining each other? What I'm saying is that object, they form one thing. Object during the collision, which is inelastic, object they join, they form one thing. You understand? They form one thing. That's what we mean by object joining each other. But I repeat, even if object join each other or a particular scenario occurs, if you are given the velocity, don't just look at the scenario, make a calculation, right? Because I expect you to be able to explain things of physics using calculation. Calculate kinetic energy, then you conclude. Understand? Okay. The last point. So, the total kinetic energy of the object in the system decrease. Total EK, remember EK, it simply represents kinetic energy, right? EK of the object decrease. What do we mean that it decreases? It means that initial kinetic energy is not equal to final kinetic energy. It means the kinetic energies are going to do what? To differ. In elastic collision, you understand? The kinetic energies are going to differ. The main point which I want you to take note of is that one of kinetic energy. is the one which you must not forget upon all the things which I've just shown you here about elastic and inelastic collision, right? Kinetic energy. Elastic collision, kinetic energy is conserved. And we just learned the formula for kinetic energy. Half mv squared. You understand? Simply that. Elastic and inelastic collision. We're fine, right? Okay, we're moving forward. I've just wrote the direction there. I just want to retaliate something, reiterate something. Okay. Let me reiterate something here. Direction. I spoke about it yesterday, right? Yes. Let me repeat. Direction. Talk to yourself, eh? You talk to yourself. Direction. Take my advice, man. Huh? I'm trying to become a teacher I never had. You hear me? Yes, there are things in physical sciences which I got wrong when I wrote my exam. But now I see that, how can I get this thing wrong? Sometimes I feel like going and register and write again. Understand? So take the opportunity. When I say do this, don't do your own things. Don't open a textbook. Don't tell yourself that you grab it by your head. Your head, it does not grab anything. I know that it does not grab anything. You hear me? Don't grab anything by your head, right? Take the notes of the things which I say. Write them down. You hear me? Because your head is going to disappoint you, and I will show you next week when you write the test. You're going to write the test next week. Okay, let's talk about direction. I just want you to remember that if we have an object going this side, right? Huh? And we have another object. Going in this side. This one is traveling at a speed of 10 meters per second. This one at 20 meters per second. Right? Represent their momentum. Right there. Represent their momentum. Not their momentum. Their velocity. Represent their velocity. Write their velocity and represent. You know that velocity is a what? It's a vector, right? Represent their velocity, those ones. I want to see how you write. You understand the question? Tsala the velocity da to object the tsala velocity and the direction. Interesting question. I'm interested. Write their velocity in the form of vector. Write the direction and the velocity. You just copy the velocity and write the direction. Must you start it? Must you see it? Must you see? Okay. Take out. It's fine. It's fine. I know now, my boy. Okay. Let us move forward. I want you to recognize that these objects are going in opposite direction. So, if you take right as positive, it means left is negative. This object is going to the right. It means the velocity of this one is 10 meters per second. This one is going to the left. It means the velocity of this one is negative 20 meters per second. Very important things to recognize. When objects are going in opposite direction, make sure that they differ in their sign. Don't ever make a mistake whereby an object is going this side and the other is going that side. You make their sign to be the same. You get the answers wrong. You understand? You don't make their sign to be the same. If you do that, you will get the answers wrong. You understand me, right? So make sure, make sure that you do not make such kind of mistake. In momentum, we have what? Direction. We're dealing with a vector quantity. If an object is going this side and the other object is going that side, you must make sure that the velocity of one object is negative. The velocity of the other object is positive. They must not be the same. Talk to yourself. You're not going to write that. Do you know that? You're going to forget. Are you aware? So I'm giving you this opportunity to talk to yourself. Tell yourself what I just said. Conscientize it. Speak to your mind. Are you done? Do it. Do what I'm telling you. Speak to your mind that when the object are going in opposite direction, we must write different signs. Talk to your mind. Nikki was not doing it. Nikki, are you doing it? Do it. Talk to your mind. You want to understand physics, right? There's no way. There's no way you will fail. You'll never fail. As long as you do what I tell you. You tell you, boy, you'll see it. You'll see it. You're going to get it wrong if you don't talk to your mind. You'll see, I'll give you questions. And you will forget what I told you is very important. If one object is going to this direction, the other object is going to this direction, make sure that one object takes a negative sign and the other object takes a positive sign. We can move. Are you sure? Yes. Sure. If you have told that to your mind, then myself, I am satisfied. Okay, let me show you something. After teaching you this, we apply. We apply. We will be done with momentum. We are going to vertical projectile. You must prepare your mind. Vertical projectile, it's a hell of a topic. It's a beach. You hear me, man? It's a hell of a topic. Okay. You are fine, right? Huh? Okay, let us move. You all understood, we are fine. If you don't understand, you tell me, right? And you must not be afraid of me, And this is how I am. You must love me the way I am, but I'm a very flexible person, You understand? I'm the most flexible person. I'm not flexible. I'm very, very flexible. It's because you have the grade 11 mentality. Now I'm in grade 12, guys. I'm very flexible. Okay. I want you to take note of this. You see this formula? M1V1 I, M2V2 I is equals to M1V 1F plus M2V 2F, right? You see this formula? I want you to take note of two situations. That formula can change. That formula can change. And what will cause that formula to change is the situation which is going to, okay, you hear me? What causes that formula to change is the what? The situation which is going to, okay. Even if you have serious spaces, we'll teach, it's fine. Okay. Look at this. Here is the situation. Here is a situation. Two objects, right? Two objects. They collide in an elastic collision, right? So it means initially, these objects before they collide, their momentum is going to be separate. Do you agree? Their momentum is going to be separate. This object is separated from this other object, right? Yes. So when they collide, isn't it? This is the initial time before they collide, right? Then this here in the equal sign they collide and they create this situation. You understand? This is the initial situation before they collide. This is when they've collided. But since they've collided, elastically, they separated each other. That's why they formed this situation. They were separated this side, even now they are separated. Because during the time when they collided, it was an elastic collision. The object did not join. But look at this situation. Look at this situation. I just want you to understand. Here is the situation. The object, they have not collided, right? Then, this object, they collide. Do we have two objects this side? We have one object, they've joined each other, right? When you read, take note of that situation. When you read scenarios in the question, just look, what happened? Did the object form one thing? Did the object become separated? Then you make a conclusion this side, right? Look at them. They're separated, right? Collision, they form one thing. They travel at the same velocity. You understand? Or in this situation, they collide, they travel at different velocities because they are separated. But when they are joined, they are traveling at the same velocity. Do you agree? Because they form one thing, Ajon. Here is a polo C. Just had them collided with the truck, right? The polo C collided with the truck. Then it stuck on the truck. Then the truck continues to travel. It means the polo C will travel on the speed of a truck, right? Because it is stuck there. Do you agree? Yes. They form one thing. Say, look at that situation. We are going to have what? We are going to have one velocity. Are they not traveling at the same velocity? Then different momentum. M1 plus M2. Do you see that formula can change depending on the situation? Do you understand the situation that happened? Huh? Do you understand the situation that happened? Yes. Okay. What am I saying? What made this formula to change to be like this? Look, here is two objects, right? That separated this object. Can you see? Then they collide. When they collide, they formed one object. Can you see that? Then they will travel at the same velocity since it's one object this time around. Do you agree? Do you agree, Shirandi? They will form one object. Can you see? It's like if the first object was what? Was 20 kg. The other object was 10 kg. It means they will do what? They will form 30 kg. And they will move at the same velocity. Do you agree? When they've joined each other. That's what I'm trying to do here. That's why this formula changed. So during an inelastic collision, when the object join, we're going to have this situation. You understand? We're going to have this situation where the objects are going to join each other. That there are three important things which you learn today. Very important. Recap. You learned that when we are asked if it's an elastic or inelastic collision, we make a calculation of kinetic energy and compare the answers. You learn the issue of direction in momentum, that when the object is going this side and the other object is going this side, make sure that for one velocity you have a positive sign, for one velocity you have a negative sign. It does not matter whether you make left positive or right positive, it's your choice. You understand? But you can benchmark here and decide that, okay, right is positive, left is negative. Isn't it? It's our decision. That's what we're going to do always, right? Yeah, so that we do the same thing. Then you also learn that when objects collide in an inelastic collision, they stack on each other. They are going to have one velocity we add there, mass is useful. It means it will appear as if this side we have one object, while we started with two objects, right? When the objects collide in an elastic collision, it means we're going to have two objects this side and two objects this side. Did you get it? Huh? Yeah. Okay. Are you sure? You got it, right? You sure you got it? Okay. Okay, so we have spoken about different situations for momentum. Now we will deal with the application. We do different questions from previous question papers so that we can be able to judge the standard, if the standard is hard. So for today, the lesson is concluded. Thank you. Timetable. I class teacher ngwena musi. Ukulam taikoma timetable ya lunzwa yi teacher every day. Now so honestly kuni yabuyi. Ngana technology. When I'm a baby, it's I'm doing this. It's I'm workshop. I'm gonna it's I'm workshop. Man, driving.